All right, so one of the things that's going to be really important is for us to be able to compare different distributions in some sort of standardized way. And what we're going to use to do that is something called a z-score, which gives us how many standard deviations a data value is from the mean. Another name for it is the standardized score. And the formula for it is your z-score equals your value minus your mean over your standard deviation. So if I know the population parameters, then it might be x minus, we use m for mu for mean, and we use this little guy sigma for standard deviation. But most of the time I have a sample, and so we'll use x minus x bar over that s you've looked at on your calculator for standard deviation. So what can z-scores tell us? A negative z-score tells us how many standard deviations a value is below the mean. A positive z-score tells us how many standard deviations a value is above the mean. And a z-score of 0 tells us that a data value is at the mean. So the further away a z-score is from 0, the more unusual the data value is. So let's look at this situation to see why it might be important for us to use a z-score. Suppose a college admissions office needs to compare scores of students who take the SAT and those who take the ACT. SAT scores have a mean of 1,500 and a standard deviation of 240. ACT scores have a mean of 21 and a standard deviation of 6. Bobby scored a 1740 on the SAT. How many points above the mean score did he score? So your value, 1740, minus your mean of 1500 gives you 240 points. Kathy scored a 30 on the ACT. How many points above the ACT mean did she score? 30 minus the mean is 21 would be 9. Is it sensible to conclude that because my answer in A of 240 is larger than my answer in B, 9, that Bobby outperformed Kathy on the admissions test? No, that doesn't make any sense because the SAT has way more points, also has a much greater standard deviation because of that, and so that is not a valid way to be comparing their scores. So how can we determine which one performed better? Hey, that's what a z-score is for. So go back to Bobby scoring the 1740. If we want to find out what his z-score is, we're going to find it by doing the 1740 minus the mean, 1500, and then dividing by the standard deviation, which is going to give me a z-score of 1. Once again, that's doing 1740 minus 1500 all over 240. So what that means is he's 1 standard deviation above the average on the SAT. Continuing with Kathy, her z-score is going to be 1.5 because it was 30 minus your average of 21 over a standard deviation of 6. That gives me my z-score of 1.5. So she scored 1.5 standard deviations above the average on the ACT. So who really did better? Kathy did better because her z-score was higher, which indicated a better score respectively. Let's say we have a different applicant who's taken the ACT and has a z-score of negative 0.667. What does that mean? It means that he or she scored 0.667 standard deviations below the average on the ACT. So if we want to find that, what we can do, we have z-score equals my value minus my average over my standard deviation. So this time we're being given our z-score. We want to know what the score was, that's x, minus what was our mean for ACT, 21, over our standard deviation of 6. So 0.667 times 6 plus 21 is going to give me 25 for his score. So here's the type of problem that you would get on the AP exam. At a college, the scores on a chemistry final are approximately normally distributed with a mean of 75 and a standard deviation of 12. The calculus scores are also normally distributed with a mean of 80 and a standard deviation of 8. A student scored an 81 on chemistry and an 84 on calculus. Relative to them, the students in the class, which subject did they do better on? So we want to do let's do chemistry first. So my score of 81 minus mean of chemistry was 75 over standard deviation of 12. So that's going to give me 6 over 12 or 0.5 for chemistry, aka half a standard deviation above the mean for chem. And then for calc, they had an 84 minus a mean of 80 over a standard deviation of 8. So 4 over 8, which is also 0.5. So comparative to their class, they did the same on those two tests, even though their score on the calculus exam was higher than the chemistry. So the student did equally well in each course. In an international swimming, the mean time for the men's freestyle is 50.46 seconds with a standard deviation of 0.6 seconds. For the 200-meter freestyle, the mean time is 110.4 seconds with a standard deviation of 1.4. Danny's best time for the 100-meter is 48.76 seconds, and for the 200-meter is 108.43 seconds. He can only enter one of these events. Which one should he do? So, what is more meaningful is how he does comparative to other people, so that means we want to use a z-score. So his best time for the 100-meter is 48.76. So the 100-meter is up here, so minus 50.46 over 0.6. So typing that in our calculator gives us negative 2.83 for his z-score, aka almost 3 standard deviations below the mean, so pretty darn good. So for the 200-meter, his best time is 108.43 minus 110.4 over 1.4. Which is unfortunately only negative 1.41 standard deviations below the mean. So he definitely wants to go with the 100-meter. Now I want you to try using a similar approach with this table on your paper and justify to me which competitor is a better competitor using the idea of z-scores.